but I'll start out with a couple funny ones. We had an employee speak at QCon a couple weeks ago in New York, and somebody happened to catch a picture of him pointing at a slide. And that's all it takes at Basho to become a meme. So we started Sean Cribbs holding things meme. So there's a whole web page now, and so that's the one funny one to show. Here's him holding a mutex, and here's recursive Sean. Still have no notes though. This is going to be fairly winging it here. So I'll just quickly go through the outline. And we're just going to go through a little quick intro, talk about the release engineering of Basho, Riak, some tooling, and actually forgot to delete some stuff from the outline, so rookie mistake. So a little bit about us. So we're Basho. We were founded in 2008 from some employees at Akamai. Started out as a sales company, and they actually made a distributed database to support this app. It was a Salesforce app. And they decided that the Salesforce app was pretty terrible, but the database was really actually kind of cool. So that's how Riak was born. So Basho is fully distributed. So we now are down to like one office, but we have 90-something employees, and we live in 90 separate locations. And just kind of like our database, there's no single point of failure. So if we lose the office, it's not a big deal. And we kind of jokingly call ourselves the distributed systems experts. It's kind of in jest because there's no such thing really as a distributed systems expert because they don't really work that well. So Riak is our Dynamo clone. It's a fully distributed key value store written in Erlang. It's been around for a while. It's one of the first open source key value stores. Facebook made another one called Cassandra, which is the kind of primary competitor, if you want to call it, to us. We work really hard on it. It's been around for a while, and like anything, distributed systems are hard. And so unlike Google and Facebook and some other people, we do separate repos. Because we're fully open source, everything's on GitHub, everything's open source, everything's Apache 2 licensed. Building Riak builds from 53 repositories. We have 143 open source ones. We actually have 257 repos on GitHub. But some of them are forked, some of them are private, some of them are just stupid things. But in Riak, only 7 are private, and that's for our enterprise one. And they're kind of small features. But everything's open source, which is interesting problems for us because we have a commitment to our paying customers, our open source customers, ourselves. But the one great thing about GitHub and having everything in GitHub is we have a lot of contributors. And I think I ended up getting old stuff. Oh, no, I'm good. OK. So number of people in our thanks file is 693. And that's a roll-up of everybody who's committed something to Riak. And considering we're only 90 people. And what's more impressive is I made actually a Venn diagram to describe this. So if you take open source contributors, people are willing to contribute to open source. Now you take distributed systems experts. And now out of that, you take Erlang programmers. And figured out scientifically that's exactly 693 people. And this isn't IEEE, so we'll just say that's science in my world. OK, so talk a little about the release engineering that we do for Riak. So basically, we have 2 major products. We have Riak, Riak CS. Riak CS is our cloud storage, like S3 clone built on top of Riak. And this is why I didn't want to go after Chuck. It's like we support 18 platforms, and he's like, cool, we support 8,000 Android devices. Like, cool story. So 18 platforms. I'm proud of it, but not much anymore. Shipped 250 releases, and the average number of release engineers, 0.75. I take that because before I started, there was 0. I'm 1, and I work on it kind of part-time. And then whenever we get an engineer who gets too burned out on something else, he'll help out with tools. So I'm, again, Don IEEE fuzzy math here, 0.05 release engineers. So it's respectable. It's not 8,000 Android devices, but we'll take it. Okay, so how do we do this? How do we make one of the most complicated things in computer science, like a distributed database, on all these platforms, and keep it stable and keep people happy and keep people from running to another database. So we must have a really good QA team. Actually, no, we have 0 people in QA. We have no QA team. So remember that Venn diagram with the open source contributors, distributed systems experts, and now Erlang experts. Try to find QA people that could test a distributed database written in Erlang. The only people who can test it are the people that can write a distributed database in Erlang. So we have no QA team because everyone tests. And when I mean everyone, it's everyone. Of the one principal engineer we have, he's still testing. And we kind of solve this with our branching and tagging scheme to force people, to not allow people to move on. They're forced to test because that's the only way they could possibly move on with their lives and add new features at some point. So with the branching and tagging, you have to set it up so that it allows you to do the things you need to do with the process you want. And you can't go from the other way. You can't hope for the best for people to follow the process and then branch and tag a certain way. And if you provide escape hatches for people, if you provide a way out so that they don't have to test, they don't have to make sure their stuff's stable, developers will find a way to move on and work on the next cool thing. So if you provide escape hatches, people are going to take them. And we don't want that because we want everybody to test. And this is really hard, and we had to make a lot of changes. And like I said, we modeled the branching around the desired process, and we actually took this from OpenBSD. They're like the one distribution, not really a distribution, but the one distribution that actually ships things on time. And they switched to a process like this, where they used to have the kind of common release branch and then develop kind of moved on, and OpenBSD completely stopped that. When they code freeze, that's it. That branch is locked down. You can't continue writing. So now you're only on the release branch, and your only option is to test. And again, we're not shipping a web page. We can't do the continuous integration. I would hope that you don't want a database that's pushing to new database code every 100 times a day. It's a database. You should trust it with your data. Some of them not so much. But we still want to make it easier for people to do tests, to do features. So basically what we did is we made nightly tagging and testing is very, very easy. And we use Erlang, which is kind of its own kind of quirky thing with dependencies. It wasn't quite as bad as Netflix jar map. I'm actually really glad I didn't make a dependency map now, because they would have blown us out of the water. Ours was bad until I saw that one. That one's crazy. So we have a thing called lockdeps, and it basically just walks a rebar dependency tree. Rebar is the build tool for Erlang. It walks a dependency tree, records a SHA of every dependency, and then it puts all those SHAs in one list, and so that you can get a nightly build that's reproducible at any point in time. So make that really easy, test on that, but that's not what you want to ship into production, because now you have all the SHAs in one spot, but every single one of your dependencies has no real tag. So to make testing easy, we did that. But final tagging is still pretty hard and annoying. But that's okay, because final tagging should be final. It shouldn't happen, for us, it shouldn't happen every day. If we were doing a release to a database every day, it'd be fairly worrisome. So final tagging is hard and annoying, but that's on me. I can write my own tools, and I can do whatever I need to do to make it nice. And it's just one of me, but it'd be easy for 2 people. But I don't want the developers to be really comfortable with tagging and releasing the whole product. And I'm going way too fast. Without my notes, I just all disheveled. Sorry about that. Now I look at the time wow, that should have taken 5 minutes. Everything we do is based on what customers we have, and who we ship to, and that's the same for all release engineering. And customers isn't always obvious who the customers are. There was a slide earlier, and I can't remember who had it. So our customers basically are the end user of Riak, open source users of our code, the developers themselves, and us as release engineers. I as a release engineer and the tools team. So end user, this is obvious. People who pay for Riak, who buy our database, who we ship to, and they have support contracts. Or it's also just people that download it. And they expect a certain quality. So if they are installing the React package on one of 18 supported platforms, they expect that first impression to be right. And that's on the release engineering. Whether or not the database itself works, whether or not there's like split brain problems or any of the crazy distributed systems problems out there in the world, those problems are kind of removed from release engineering. Except that as a release engineer, you're like the last 10%. You're the last signature on the line. So when all that code's been written and you're the last one to say okay, your real concern is the end user going to get a good experience? At the same time as doing releasing, I also do all the packaging, so there's a lot of pressure on me to make sure that RPM-I or dev install or apt install is going to work and be a good experience. So end users are our prime concern. What's interesting for us, though, is our open source users are really big. And it's not just open source users building it from source, using Riak. In that case, we need our builds to not just be in our magical build system or sandbox. We need it to work for anybody. We kind of limit ourselves on what tools we use just so somebody can still type make. Make package, make install, whatever it is. There's some magic behind the scenes, but when it comes down to it, you can usually check out any React repo, run make, and it's going to work. And some of that we accomplish by checking the build tool actually into the repos, and that's like a complete religious debate. But rebar is checked into all our repos, but that requires you to not have anything installed on your system really to build it. But the other thing about open source users, some of them might not even care that we're making a database. Some of them might be using React Core is a distributed systems framework for just organizing nodes and passing data around it like basically a distributed system. And we have users that use React Core for things that are totally not databases, just regular distributed apps. And we have to care about them too. So that the argument about one repo versus multi-repo, for us, multiple repos has supported this thing. We make Web Machine, which is a REST tool in Erlang that a lot of people use outside of React. We make the one good logger for Erlang called Logger, L-A-G-E-R. So we make a lot of tools that people use, and we have to be concerned about that. And so all of this is to say, these are the things we have to be concerned about when we're making tools and when we're considering releases. Developers of React, like the 693 committers, their lives have to be easy. So one of the biggest things that Reid would talk about is the tools we have can't just be internal to our own development. It has to give feedback to other people trying to contribute. So developers of React, we have to keep them happy, because if you're an open source project and you have no developers from the open source world, you're not going to do very well. And the hope is, if anything, in the future, no matter what, it's not just our company that owns this. It's all Apache 2 licensed, so anybody can take it. And so the hope is that it just gets better and better over time, no matter who's working on it. The last customer for me is very selfish. It's myself. If your release process is terrible, if the tooling's terrible, and it makes your life really not fun to be a release engineer, then you're not going to do a good job at it. If it's really repetitive, you're going to make mistakes. I've been releasing React, 200-something releases for 3.5 years, mostly by myself and with a few other people here and there. And if it's too repetitive, I'm going to make a ton of mistakes, even though it's just completely second nature. So now we're going to talk a little bit about tooling. And again, people have brought up things. I didn't know if people are going to know about some of the tools. So it might be a little repetitive. I'll talk about Buildbot for a second, then I'll hand it off to Reid. So we use Buildbot for our builds. I thought it was actually going to be more controversial because most people I know use Jenkins, but then it seems like everybody here uses Buildbot, so kind of wasted a whole slide. Buildbot's really good for really complex things. I mean, Jenkins is kind of pretty. The Buildbot UI by default is really, really terrible. Because we have 18 platforms and all the different products, and then we do all our testing on it, I mean, I think the horizontal scroll takes a while. I mean, it's at least 4 or 5 finger swipes to get across on a Retina display. So the UI is bad, but the config is really, really good. Writing just a for-I loop on like every platform with every repo and randomizing it so that you build different repos on different platforms every time and not having to like spawn out to a million machines. We're still a startup, so we don't have unlimited resources. If you want to send me some unlimited resources, like I'll take it. I can give you my SSH key. Give me a VPN access. I'll use some of your unlimited resources. But so yeah, so stuff like that, randomizing what platforms things are built on. It would be really, really hard in Jenkins, but it's simple. It's like 2 lines in Buildbot. So we're a big fan of that. And actually, the GitHub status API, this talks how we use GitHub, because we're really invested in GitHub. So the GitHub status API works really well with Buildbot. So every commit comes in, goes to Buildbot, it does its thing based on what repo name it is. What certain repos have certain, if it's like the Ruby client for Riak, it does different things, and if it's a React core feature, if it's written in Erlang, it's going to go through different testing than if it's written in Python based on the repo. But the best thing is all that stuff gets posted back to the actual PR, and it's attached to the actual SHA of the commit. Not to the PR itself, to the actual SHA of the commit. And this was brought up too. If you change the commit on the pull request, it's going to have to go back through the whole round of testing. But attaching it to the PR is super important. I mean, Travis CI, it's like a whole startup, and all it is basically the GitHub status API. It's building on their VMs and posting back to it. And so yeah, if you haven't used that and use GitHub, it's really easy to use, and it gives really, really good feedback. So despite my notes, I know the next slide is going to be Reid's. So I'm going to hand off real quick, and maybe I'll try to get up while you switch the mic. If I can get it off.
All right, so as Jared said, my name is Reid. I am one of the developers who is sort of the audience for this tool. And if Jared is half of the Relange team, I guess I'm the other quarter. So the title of this talk was Building Enterprise Software on GitHub. So I'm going to talk a little bit about some of the tooling we've built on top of GitHub. And this isn't to say that GitHub's the greatest thing ever. I'm going to talk a little bit about why we've used GitHub, but my takeaway certainly should not be that you all should be using GitHub. But I want you to consider some small tools that you can use on top of some existing tooling you may already have in place. So we're invested in GitHub, and we're invested for a couple different reasons. As Jared said, we have over 200 repositories in GitHub. It takes time to move to a new system that may have some new advantages. So there's other code hosting tools. There's things that we could use locally. But that takes time and effort, and we have to really evaluate whether those things are going to be enough of a benefit for us. We have a lot of issues in GitHub. Some of our repositories have over 1,000 issues in them. So just migrating those takes time. Have any of you ever switched an issue manager before? Gone from something to Jira or something like that? It's a lot of work, right? It's a huge pain in the ass. And you don't really know how well the new tool is going to fit your process until you're pretty far through it. It's really hard to go back out. And as you're doing that, do your developers have to file issues in both? Or do you write some tool that synchronizes both ways? In which case, you're already writing a tool. Maybe that little tool you write can do some of the things that the tool you're using now doesn't provide. We have a big community in GitHub. As Jared said, there's over 600 people who have just contributed code. There's a lot more who have filed issues on GitHub. And for better or worse, for open source software, GitHub is one of the sort of de facto places that people go, and people tend to like the interface. Fortunately, GitHub has an API for pretty much everything that you can read or write from the GUI on GitHub. There's an API to interact with that. And for us, that's worked out really well. It's meant that we've been able to prototype little tools that filled some need that someone else might have to completely switch an issue tracker or code management tool. We've been able to prototype some tools for that, and I think that's been really successful for us, and a few of those I want to share with you. At the root of everything we do, since we're shipping a database to customers, quality is really, really important to us. So as we develop software, we need to make sure that we ensure this quality. For us, the two sort of main things we've used to ensure quality are tests and code review. Both of these we can go into a lot of detail about. We have a bunch of different types of testing. We have your traditional unit testing. We use a lot of something called property-based testing. We use a tool called QuickCheck, which some of you may have heard of. We use static analysis as well. And we also do pretty traditional code review on everything that ever gets merged into our code base. So to sort of set the stage for what we are working with and to motivate why we make these changes, I want to talk about how things were back before I sort of joined the tools team and said, hey, I'm inspired to make some of these changes. As Jared said, we were using Buildbot for tests. And this is actually working really well for us. I'm going to talk about a few specific cases that we could use Buildbot better. But Buildbot was working well for our tests. We were using GitHub pull requests for code review. So you would just comment in line +1 on this. But we ran into some problems with this. Both of these were really nice tools for us, but we are still dealing with humans here, right? So just because we have the Buildbot result that has a pass-fail doesn't mean that someone actually checks it before the code gets merged. And, right, so people are lazy. They say, oh, well, that test isn't failing because of my change. I'm going to go ahead and merge it in, right? And that's understandable. People are lazy. They don't want to have to go fix someone else's test when this happens. Further, when you just sort of use Buildbot to test your feature branches or master or develop, you find out when things break after they've already been committed. For a feature branch, that's not a big deal, right? But when I merge something into master or develop, I'd love to know before it gets merged whether that merge commit is going to break or not, right? Just because my feature branch passes doesn't mean that when I merge it into master, it's going to stay succeeding. That merge may actually have some merge conflicts that someone has to resolve, or it may interact differently with the feature. We're not just setting the SHA of master to fast forward. There may actually be a merge here. And code review is not on a specific SHA. We take code review seriously, which means that in almost every case, there's some back and forth where the reviewer gives you feedback and you push more commits to this branch. And so if someone gives a +1, but then the developer decides to push some more code up to this branch, should that +1 still count, or should we have to review the new SHA? We've decided for us, we want every change that you push to be code reviewed. So as you respond to review feedback, if the reviewer is ready, they only +1 a specific SHA now, not just this branch. And in doing this, we wanted to make sure that all of this was as automated as possible. We don't want to let ourselves as humans be lazy and make mistakes. Well, we do want to be lazy, right? We want to write software that helps us be lazy, but we want that software to help prevent us from making mistakes. So we've been using a tool called BORS, which is a simple Python tool that came from Mozilla. It's used for Rust and Servo. Rust is a new systems programming language out of Mozilla. And it's a simple bot for code review, and it's a bot for integration tests. And your bot has to have a GitHub account, so you got to give it a funny avatar, filled with inside jokes and stuff. But I'm going to show you quickly how it works. So this is a pull request comment. So you can see here that someone's made a pull request, and Sean has, this is one of the commits in there. This is the current head of this feature branch. And Sean has said +1 to that SHA. And BORS comes, it's just a cron job. It runs every 5 or 6 minutes. And it comes and looks at the open pull requests and says, oh, hey, there's one here that this pull request has been code reviewed. So now I've seen approval from Sean. It's going to go and create an integration branch. And then Buildbot's going to pick up on that when that gets pushed and run the tests. But this integration branch is not just the tip of the feature branch. It's actually doing a merge with develop. This is the resulting SHA that were you to actually merge this feature branch into develop or master, this would be the result. So we actually test that. And it turns out you'd be surprised how often that SHA breaks the build, but the feature branch doesn't. When you integrate things, a lot of times that's when things break. That's also the hardest time to sort of go back and track down where things broke sometimes. So here, luckily, all the tests pass. So now we can ask the tool to merge. And there's a reason that we don't actually just click the merge button on here, too. We're trying to be really safe here, and we want to make sure that we never actually let develop get ahead of us before we merge this in. Because now that merge commit that we made is actually no longer valid. If another pull request gets merged in and develops master or develop, that merge commit that we made and tested is actually no longer valid. Develop has moved on. Or maybe the developer has pushed another commit to this branch and code reviews happened again. So before the tool merges, it actually looks at the target branch and the branch that you're trying to merge in and make sure that those are still the same SHA that are the two parents of that merge commit. And if they're not, it says, hey, this merge commit that we made and tested is actually stale. We need to start over. We need to make a new merge commit that takes in if there's some new commits on that feature branch or develop or master has moved along. We need to start our test over again. This way, whenever master or develop is advanced, it's always to a SHA that we have tested. And this is, aside from some non-deterministic tests, this has basically meant that master and develop never breaks for us, which is really nice because me as a developer, I don't have to waste time dealing with someone else's mistake. I can just make sure that whenever I check out master or develop, it's going to build. So another issue that we've run into is that, as Jared said, we have a bunch of different repositories. For better or worse, Riak is 53 repositories or so, which is good for our community. It means it's really easy to contribute to just one of those sub-projects if you don't care about Riak overall. We've done a good job of making the sub-projects relatively general and not Riak specific. But it means that as we're trying to get close to a release, each of these sub-projects might have some changes that we're all trying to get in at the same time. And we want to know, hey, how far are we from releasing Riak 2.0 or Riak 1.4.9? And we have several concurrent releases. As one of the other speakers was alluding to, sometimes you have customers that pay you a lot of money to backport fixes. They don't want to run the most recent version of your software, but some specific fix that you put into your new version, they really want backported. So we'll often have several concurrent releases that are being worked on, and we want to be able to track all of this across all of these repositories. This is the point that you might be thinking, well, let's just move to Jira or something like that that allows you to have multiple projects and sort of introspect how they work together. But GitHub does have these milestones, right? So this is an example from Riak CS. We have different milestones here. You can just assign an issue to a milestone, see how far you are. But the problem is these don't get aggregated across multiple repositories. But we thought, GitHub has an API. Can we just create some tool that does that view for us? Just a little Python script that every 5 minutes runs. We hard code the list of the repositories that we care about. So there's a list of 25 or 50 repositories that it goes, and it asks for all the milestones, and it just aggregates them together. This took a couple hours to sort of prototype and a few days to get it working, but this was a hell of a lot less of a change than switching our issue tracker. And if this failed, nothing is lost. This doesn't, the users don't have to care about this. This is another side view that we have at our own data that we've written. And if it failed, not a big loss. So now we're able to aggregate all of these milestones that have the same name across our different repositories and gain insight into where we are across them while still being able to have multiple repositories. Then if you zero in on one of these milestones, you get a breakdown of all of the issues there. These are all just links to GitHub. This is not a separate tool that has to sync back and forth. It's just another little view that we get to not have any big friction changes and have new insight by spending a few days. So we really focus on simplicity here. The goal was just, can we make the stupidest, simplest thing work to achieve this need without having to search for a whole new tool. So it's a simple static site, including CSS and HTML templating. It's maybe 500 lines of code. And it's updated with cron. It doesn't try and do any smart state things to listen on webhooks. Every 5 minutes, it just goes through all of these issues and repositories and updates a static HTML file. The cool thing about that too is then we can save old timestamped versions of this HTML or JSON. And despite the fact that GitHub doesn't have any sort of history queryability, like, hey, the last time we were a few weeks away from a release candidate, how many open issues did we have? Now we can actually, because we're saving our own data just in a JSON file, we have a chance of actually going and answering some of those questions without having to wait for someone else to build that tool for us. We don't have to change. We can just sort of build our own lightweight tooling off the side. So this static site generator is actually totally open source now. I don't claim that it's well documented, but it is Apache 2 licensed. So if this is something that's pertinent to your organization, please feel free to use it. I think I can speak for all of us at Basho that we found it to be quite useful. Here's some more links of things we've talked about. So you can, if you're interested in learning more about what we do at Basho, as Jared said, our two products, Riak and Riak CS, are both Apache 2 licensed, so you can go play with them, read the docs. Issues is that sort of milestone coordinator that I talked about. And then BORS, which is that tool from Mozilla, lives at this GitHub link. And I believe there's a motivating blog post on there. But the basic idea of BORS, again, is that master or develop should never break. And that includes making sure that you test that merge commit before advancing master or develop to that merge commit, which is something that, crucially, I think tools like Travis CI leave out. It's a little escape hatch that the merge commit can introduce bugs that break master and develop, and that's a little escape hatch that we've been trying to close out. Anyway, I think that's it for us, and we'd be happy to take questions. Thank you.
See, I had one question. You guys talked about how you're using GitHub and almost seem resigned to the fact that you're stuck on GitHub. You have all this stuff invested in there. So I'd like to get your perspective in terms of if you had your way, is there a better tool out there for you if you had a clean slate?
Sure.
Let's see. Is this one on? Is it on? Nope. Yes? Okay. So the thing with GitHub is you can definitely do like GitHub Enterprise, and that's local, or Stash, or any of those things. But because we're open source, having a separate internal repo and external repo doesn't really work for us because then there's that sync up. Like we're gonna have local code, but then there's the public code, keeping those in sync. And we actually started with Bitbucket. And if you look at our contributions and people downloads and all of those things, when we switch from Bitbucket to GitHub, it's basically a hockey stick. Bitbucket, we had, I don't know, like 20 people, starring the repo and like very few downloads, no contributions. Switched to GitHub and it was through the roof. Yes, GitHub has its problems. It had some outages, here and there. But you can solve that with some local mirrors and caching to make sure you don't go down, make sure you don't lose your code. But as far as I know, I've looked around, there's no real good solution to owning your own availability and also providing a good service for other people to use your code. Because I think a lot of people have enterprise GitHub or local Stash. Open source is a second thought to them, or maybe a third or nth thought to them, where they're building their product and then when they have time, they'll sync up the repos. Whereas all of our stuff is open source, so it's all built from the open source itself. So I have my concerns. We talked about this at lunch. I have my concerns with availability and somebody else owning my code. But you can solve some of that with mirrors. But the benefits we get from the user, just the sheer amount of users on GitHub is far outweighs the negative. So, anybody else? Thanks.
Thank you.